Acids can be weak or strong, and the definition of acid strength isn't about how much damage it will do to your skin or how much it will burn you, but it's about how much it dissociates when you put it into water, how many ions it will form. And remember, that's called an electrolyte. The more ions we have, the more electricity it can conduct. So our weak acids, which is hydrofluoric acid, will not break apart completely. Some hydrofluoric acids will stay together and some will dissociate into ions. So we don't have complete ionization of this acid, and that's why it's a weak acid, and it's also a weak electrolyte. A strong acid, such as hydrochloric acid, will dissociate or ionize completely in water, which means every single molecule will break up into an H plus ion or proton and a chloride ion. And so since this dissociates completely, everything is turned into products for our strong acids. For our weak acids, things are not completely dissociated, so we have an equilibrium and it can go back and forth, and it's mostly reactant heavy, so it really lies far to the left. So most of it does not dissociate for weak acids. Interestingly, hydrofluoric acid will absolutely destroy your tissue. In movies, that's what they use to dissolve the bodies. Where hydrochloric acid will just give you some burns. If you get enough hydrofluoric acid on you, and we're just talking about just a little spill on your hand, it doesn't matter what they do. They can take you to the hospital, whatever, you're a goner. So it's super dangerous, but it's considered a weak acid. So back to what I was saying, it's in equilibrium. It doesn't all break apart. So that's part of the reason why it's so dangerous. It can absorb actually into your cells and then break apart. But because it's in equilibrium, we can write an equilibrium constant. Yay! And we call that Ka. And it's just the equilibrium expression for an acid and its products over reactants, just like we were doing. Okay? Ignore the ice chart there. That is for AP Chem. And sometimes you'll see it written generically, an H plus plus an A minus, and HA is my acid. So A is our anion there, which is F. Okay, and again, don't worry about that ice chart. Okay, here there's no equilibrium because it's strong. It completely ionizes totally into those products when you put it in water. Okay. And so when we put in something that ionizes completely, if it's 3 moles or 3 molar, it could be concentration or moles, it will dissolve into 3 molar H plus and 3 molar Cl minus, or 3 moles of H plus per liter and 3 moles of Cl minus per liter. If that had a 2 in there, it would break apart into 3 and 6. So we've done those kind of things before where we see how things break apart into water. Weak bases and strong bases are the same concept. Our weak bases don't dissociate or ionize completely in water, and our strong bases do ionize completely in water. And since our weak bases don't ionize completely, they're also a weak electrolyte, and they're in equilibrium. And our equilibrium expression for a base is denoted by Kb for base. Same thing, products over reactants raised to whatever power, just like what we did before. Okay?